topic is maximum power transfer theorem and problems based on that statement. What is this maximum power transfer theorem? It states that in any linear bilateral network, a load will receive maximum power from the source when the load resistance is exactly equal to Thevenin's resistance of the circuit. Statement, once again I am repeating. It states that in any linear bilateral network, a load will receive maximum power from the circuit, from the source, when the load resistance value is exactly equal to the Thevenin's resistance of the circuit. That is, for any linear bilateral network, maximum power will be delivered to the load when this RL is equal to RTH. Okay, so when RL is equal to RTH. So that is a conclusion in a simple way. So maximum power delivered to the load when RL is equal to RTH. RL is nothing but load resistance and RTH is nothing but Thevenin's resistance of the circuit. Now, if there is only source resistance, there are no other elements. There is only source resistance, there are no other resistances in the circuit, then this maximum power is delivered from the source to the load when RL is equal to RS. When RL is equal to RS, that means load resistance is exactly equal to source resistance of the circuit. So now, and what is that maximum power value? The expression for maximum power is given by, that is denoted with P max, that is given by VTH square by 4 RTH. VTH square by 4 RTH. So we know where VTH is a Thevenin's resistance of the circuit and RTH is a Thevenin's, VTH is a Thevenin's voltage of the circuit, RTH is a Thevenin's resistance of the circuit. Okay, already in my previous lecture, we have seen Thevenin's theorem. In my previous lecture, I explained about this Thevenin's theorem where we come across this Thevenin's voltage VTH and Thevenin's resistance RTH. So, this is the expression for maximum power. P max is equal to VTH square by 4 RTH. Now, so this is a circuit to calculate that maximum power. So, for the given circuit, we have to find out the Thevenin's voltage and also Thevenin's resistance RTH and with the load resistance connected across the load terminals. So here AB are the load terminals where the load resistance RL is connected, and here IL represents current flowing through the circuit, current flowing in the load resistance, that is the only current flowing in the circuit here. So this is the circuit. So once again, this maximum power transfer theorem statement. So in a linear bilateral network, maximum power will be delivered to the load when the load resistance value is exactly equal to the Thevenin's resistance of the circuit. Okay, that is RL is equal to RTH. And in the circuit, if we have only source resistance, there are no other resistances in the circuit, then the maximum power will be delivered from source to the load when the load resistance value exactly equal to the source resistance. RL is equal to RS in that case. And the expression for P max is given by maximum power, it is given by VTH square by 4 RTH. VTH square by 4 RTH, where VTH is the Thevenin's voltage of the circuit and RTH is the Thevenin's resistance of the circuit. So that means if a problem is given to ask to calculate maximum power, delivered to the load, then we have to calculate VTH and RTH. VTH and RTH. Then only we are able to calculate that maximum power. So that is about the maximum power theorem statement. Derivation. The derivation for this maximum power. So we have seen the expression for maximum power is given P max is equal to VTH square by 4 RTH. So the derivation for that, how it is given. So here see that it is explained like this. Here, so for the circuit, okay, we have seen, so in the circuit, previous circuit, the current in the circuit is given by here IL is equal to VTH square VTH by RTH plus RL. So current in the equivalent circuit, IL is given by VTH by RTH plus RL. Now, power delivered to the load. So in case of this is a simple DC circuit. So in case of a DC circuit, power delivered is given by, okay, we know that power is given by simply either product of voltage and current, which can also be given as I square R or V square by R also. Now here the power delivered expression is considered I square R. So here I means IL, R means RL. Okay. So substitute for IL. So we have IL from the equivalent circuit VTH by RTH plus RL whole square into RL. Now we want to determine the value of RL for maximum power transfer. Okay. We want to know the value of RL for the maximum power to be transferred to the RL. How it will be obtained? So differentiate the equation, this power expression, this power expression with respect to the variable resistance here, variable parameter, that is here RL, and equate it to 0. So that is, see that dP by first derivative of the above power expression, dP by dRL. Okay, dP by dRL equal to 0. Now, so see that what is that power expression? This is a power expression. So see that what is that we are going to get. So see that. So this is simply like U by V formula. So that is given by differentiation of U by V is given by U into V dash, okay, minus V into U dash by V square. So U by V formula, that is a U by V formula, first derivative of U by V formula, U into V dash minus V into U dash by V square equal to 0. So what? So here see that. So here for us, this is the expression dP by dRL. This is whole power expression, right? So VTH by RTH plus RL whole square into RL. Okay, that is the whole power expression equal to 0. So now, so apply this whole equation. This is U, this is U, this is V, this is V. After applying U by V formula for the above expression, after simplifying, equate it to 0. Finally, this is the one we get. Okay, RL is equal to RTH. RL is equal to RTH. Okay. So that is how we can, okay, we get the condition. Okay, whatever the statement says, that is how it is obtained. RL is equal to RTH. Load resistance value is equal to Thevenin's resistance. Now, finally, give the expression for power. Expression for power, that is, okay, I square. What is the power expression for power? This is a whole power expression. So in that, substitute that in place of RL. Okay, use this condition, RL is equal to RTH. Finally, we get it as VTH square by, okay, so we know that this is a power expression. This is a power expression, VTH by RTH plus RL whole square into RL. So here I'm substituting in place of RL, I'm substituting RTH. RL is equal to RTH. So this is given by VTH square by 2 RTH whole square into RTH. VTH square by 4 RTH square into RTH. RTH gets cancelled. So finally, equation is, our expression for Pmax is given by VTH square by 4 RTH. So that is how it is derived. Expression, condition for maximum power, and also expression for maximum power. Now, problems based on the maximum power transfer theorem. So consider this problem. For the network of figure below, calculate the value of RL for maximum power to RL, and calculate the power delivered under these conditions. So for the network of figure below, this is the figure, okay, given. Calculate the value of RL. Calculate the value of RL for maximum power to RL. So that is the first thing they ask to calculate. Okay, value of RL, calculate the value of RL for maximum power delivered to the RL. So what is that? We know that. So from the maximum power transfer theorem statement, we know that the maximum power will be delivered to the load when the load resistance is exactly equal to Thevenin's resistance. Okay, so if we calculate the Thevenin's resistance of the given circuit, that is a value of the RL for maximum power transfer. So then, okay, first we do this first part, then we go for the next, what they ask. Okay, they ask this power delivered under these conditions. That means maximum power they are asking, maximum power transferred or delivered. So this is a given circuit. Here, this is a RL value. Okay, RL, it is given across the terminal CAB. So here, see that first part, doing the first part. So in the network, the maximum power will be delivered to the load when RL is equal to RTH. RL is equal to RTH. So that is already we know. So finding the RTH for the given circuit. So we know the procedure to calculate the RTH. Procedure to find RTH. So already we know that. So Thevenin's resistance, to calculate Thevenin's resistance, replace all the voltage sources with a short circuit and current sources with the open circuit. In a given circuit, replace all voltage sources with short circuit and current sources with open circuit. So here in the given circuit, we have only voltage source here. So that is replaced with a short circuit, and then remove the load resistance. In place of that, we find the equivalent resistance, that is nothing but Thevenin's resistance, RTH. Okay, remove the load resistance and find find the equivalent resistance at that place. So for this circuit, the resistance RTH is given by Thevenin's resistance RTH is equal to. So we know that how to calculate. We start from the other side. Here at these terminals, across these terminals, we want to calculate. So we start from the other side, means here. So these 3 ohms and 6 ohms are in parallel. Okay, if we start reducing the circuit from this side, so first if we see these two are in different paths, so currents are different, so that means they are in parallel connection. So first, okay, we have to calculate the equivalent of these two elements, 3 and 6 ohms. So that means 3 into 6 by 3 plus 6. So then the resultant of these two will be, okay, so the 3 and 6 combination in series with the 6 ohm. So the resultant of these two is 3 into 6 by 3 plus 6 means 2 ohm. So these 2 ohm and 6 ohm are in series. So then 2 plus 6, it gives the 8 ohm. Okay. So the final value of the R, total resistance, or Thevenin's resistance here, it is given by 2 plus 6, that is equal to 8 ohm. So for the first part of the question, okay, calculate the value of RL for maximum power transfer to RL. So that is given by RL is equal to, okay, we know that load resistance value equal to the condition according to the theorem statement, the load resistance value equal to the Thevenin's resistance of the circuit. So which is calculated here as, okay, 8 ohms. So the RL value is given by 8 ohms. So that is the first part. Next part of the given question, they ask you to calculate the maximum power delivered to the load under this condition. Okay, so we know that maximum power delivered expression, maximum power delivered is given by P max, which is given by VTH square by 4 RTH. VTH square by 4 RTH. So already we know in this expression RTH value we calculated, okay, which is 8 ohms, and then VTH value, okay, we need to calculate that VTH value for the given circuit. Okay, so for the given circuit, the to find VTH, okay, is given like this. The circuit is given like this. So actually we know already how to calculate VTH, Thevenin's voltage, the procedure. To find Thevenin's voltage, we remove the load resistance. Simply only we remove the load resistance, okay, across the load terminals, and find the load voltage. That means open circuited voltage, okay, open circuit voltage, which is also nothing but Thevenin's voltage across these terminals. Remove the load resistance, and at that place find the, across those terminals, find the voltage. That voltage is called Thevenin's voltage, and without disturbing the remaining part of the circuit. Only load resistance is removed, and there find the voltage, that is VTH. So here this is for the given circuit. Okay, we removed load RL here across the AB terminals. So now how to find the voltage here? So based on our previous knowledge, okay, applying the previous circuit analyzing knowledge, so we learned so far concepts how to find the voltage here. So from this circuit, finding the voltage here means this is open circuited, means there is no current in this 6 ohm resistor. So voltage VTH is nothing but, here VTH is nothing but voltage across this voltage here is nothing but voltage across this 6 ohm resistor. Voltage across 6 ohm resistor. So find the voltage across the 6 ohm resistor for this circuit. Finally, it means you calculated VTH value. Okay. So now, how to find the voltage across the 6 ohm? So to find the voltage across the 6 ohm, find the current in the 6 ohm, right? Its resistance value is 6, already know, given. So if we are able to find the current flowing in that 6 ohm, let us say that current flowing here is, let us say, current I in that single loop. So then it is given by 6 into current flowing in that 6 ohm resistor element. Now, how can we find this I value from this circuit? Okay, see, okay, it is given by 6 into applying KVL here. Okay, I value is given by Ohm's law. Okay, or KVL 6 by 3 plus 6. Yes or no? So in this single loop, if we apply KVL in this single loop, the I value is given by this V voltage, supply voltage 6 by 3 plus 6. So that's why simplifying 6 by 9. 3 to 3, okay, so finally it gives 4. So that's what it is mentioned here. Thevenin's voltage is given by 4 volts. Thevenin's voltage VTH is equal to 4 volts. Now, finally, come to the calculation of maximum power, that is given by P max VTH square by 4 RTH, VTH square by 4 RTH. So substituting the values of VTH and RTH, VTH and RTH, which is given by VTH is 4 volts, so 4 into 4 by 4 into RTH we have 8 volts. So substituted, which gives 0.5, which gives 0.5 power. So units are watts. So uh, that is how the maximum power is calculated. Maximum power is calculated. So I hope you understood. So calculating the maximum power. Next problem is given like this. One more problem. In a series circuit, source resistance is 45 ohm and load resistor is for RL with 20 volts DC supply. Okay, they are telling that source resistance is 45 and there is a load resistor RL with 20 volts DC. Supply is 20 volts DC. Now, if the RL is a variable of resistors, okay, they are telling that RL is a variable of resistors 10, 20, 30, 40, 45, 50, 60, 70 ohms respectively. Okay, so respectively, calculate different values of RL are mentioned. Calculate for what resistance of load maximum power is transferred. Okay, that is the first thing. Calculate what resistance of load maximum power is transferred, maximum power is delivered. Okay, that is the first thing. Then remaining some more, or they're asking to calculate. So we know that from the maximum power transfer theorem statement, maximum power is transferred or delivered. Okay, what is the condition? RL is equal to RTH. Okay, RL is equal to RTH. If only source resistance is present, there are no other resistances in the circuit, then RL is equal to RS. Here, see that. What is a circuit? They have given only source resistance and load resistance with the supply source. And there are no other resistances. Right? So, the value of resistance for the maximum power transfer to the load is given by RL is equal to how much? So we know that we can say RL is equal to RS. So that is the first part. So load resistance value is equal to source resistance. What is a? Okay, so that is the first part. So RS is 45. So RL is equal to, whenever RL is equal to 45, then the maximum power is transferred. So that is the first part. So that is explained here. So showing the circuit. So from the given data, the circuit is drawn. Okay, for understanding, the circuit is drawn. So that is shown like this. Input DC 20 volts, RS is 45, and RL is given variable, which is a variable between 10 to 70 ohm, right? Between 10 to 70 ohm. So yes or no? That is, those are the values. Different values are given starting from 10 to 70. That's why it is drawn like this, the circuit from the given data. Okay. Now, first part of the given question. For the maximum power, okay, from the maximum power transfer theorem statement, maximum power is transferred from source to load when the load resistance value equal to source resistance. Okay. So, because why? Because already I mentioned only source resistance is present in the no other resistances. Yes, right? Only source resistance is present, no other resistance. That's why RL is given by maximum power is transferred when RL equal to RS. That means RL value is equal to, therefore RL value equal to 45. So that is the first part of the question. Next part. What else they asked? See that? So next they asked maximum power value, current and voltage drops in each case. Maximum power value and current and voltage drops in each case. So that means for each value of RL, for each value of load resistance, we need to calculate, they're asking to calculate the current in the circuit and also voltage drop, okay, voltage drop across the load, okay, as well as source resistance also, and also maximum power also they're asking. Okay, so maximum power means here how to calculate actually. So that is from the for the previous step only. Maximum power, that is nothing but maximum power. How do we calculate? P max is equal to, here only we calculate maximum power value, VTH square by 4 RTH. So what is the VTH value? VTH value here we have only two elements, right? RL and RS. So VTH is nothing but source voltage 20 square by 4 into 45. So that is the maximum power value. Maximum power value. Next step, they ask to calculate current and voltage drops in each case. Okay, so that means for each value of RL, calculate the current in the circuit and also voltage drop. Okay, voltage drops. Now, look here. First, for RL value 10 ohms. For RL value 10 ohms, I calculated the current in the circuit. Vs by RTH plus RL. Right? So, for RL is equal to 10 and RS is equal to 45. What is the current in the circuit? This is 20. The current in the circuit is, let us say, I. V20 by Vs by Rs plus RL. That means 20 by 45 plus 10. So this is the current in the circuit. Next, voltage drop. Voltage drop across the load. So VL is given by current in the circuit I multiplied with the load resistance value, that is 10. Okay, here RL is equal to 10. So for this value we calculated voltage drop. And also power in that case we can simply calculate power in the, okay, power is given by, actually this is not required, so because they are not, it's not the question, so they ask to calculate current and voltage drop in each case. So we calculated current in the circuit, voltage drops. So voltage drop, voltage across, this is a voltage drop across the load. If you, okay, voltage drop across the source is given by I into RS. So that is a voltage across the source resistance. So that is for RL is equal to 10 ohms. Calculated the current and voltage drops. Next, for RL is equal to 20. Current is, okay, 20 by, the circuit is same, only RL value is here 20 and RS is equal to 45 and this is 10. So I is given by 20 by 45 plus 20. So this is I and VL is I into RL, I into 20. I is from here. Next, voltage across the source resistance, I into RS, I into 45. This is same. This is not going to change. Okay, because I changes, this value also changes. Okay. So this is how for 20 ohms it is calculated. Next, for RL value 30 ohms. For RL value, so we have values, different values, right? So for each RL, so next RL is equal to 30 ohms. Calculate the same thing, same manner. Calculate the current and then voltage drop across RL as well as source resistance. Then 40 for RL is equal to 40 ohm current in the circuit and voltage drop across RL and source resistance. Then 45 ohm current in the circuit, voltage drop across the load resistance, voltage across the source resistance. Then RL is equal to 60 ohm. RL is equal to 60 ohm current in the circuit, voltage drop across the load resistance, voltage drop across the source resistance. Next, RL is equal to at last 70 ohm. That is a maximum value given in the question. So for that RL value, calculate the current in the circuit and voltage drop across the load and also voltage across the source. So that is how for this question calculated maximum power in the circuit, maximum power in the circuit for this question, and also current and voltage drops in each case, in each case of RL. So um, so that is about the maximum power transfer theorem. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.